Hello, my name is Josh Obert, and I am a GIS analyst with the ACPF National Hub. In this video, we're going to explore the next tool in the toolbox, D8 Terrain Processing, where we will get to develop our filled DEM, flow direction and flow accumulation rasters, as well as a hillshade. We have ArcGIS Pro open, showing our watershed boundary in yellow, on top of our pit-filled hole-punched DEM, as seen by the name in the table of contents, having the _P. We'll move our mouse over to the ACPF toolbox, expand DEM preparation, and we will find the second tool in that list, D8 Terrain Processing. Double click it. This tool has 6 options. 2 are inputs and 4 are outputs. The 2 inputs are our DEM and the Z factor. Like the first tool we ran, since the DEM is within our map, we are able to select it from the drop-down for Input Unfilled DEM. Within the drop-down, we will select E1MP_P, our DEM. Once we select the DEM, the 4 outputs will automatically populate to store in our geodatabase with a default naming convention. We then need to enter our value in the Z factor input. Just as we did before, our XY units are in meters and the Z units are in centimeters. Our conversion factor will be centimeters divided by meters, so we enter 0.01 into the Z factor. To run the tool, we will move our cursor down to the bottom of the window and click Run. The first of the 4 outputs is the filled DEM, where sinks in the landscape are filled so water can continually flow downhill. In the top example, we show a sink, and then after the process is run, it is filled in to match the surrounding cell, so water that previously would have flowed into that sink will not be trapped. In the DEM on the left, we can see flow paths that are disconnected because they flow into sinks shown in green. But once they've been filled, these flow paths are now connected to the mainstream network. The second output is the flow direction raster. This uses the D8 approach and assigns a number code based on the direction that the water will flow. For example, if the water is going to flow east based on the change in elevation, a number code of 1 will be assigned to that cell. We can see in the square at the bottom that 1 is east, 4 is south, 16 is west, going around with a value for all 8 directions. This will be used to generate the flow accumulation raster. The third output is this flow accumulation raster, which uses the flow direction raster to calculate how many upstream cells flow into a given location. In the output flow accumulation raster, the value at each grid cell is equal to the number of upstream cells that flow into it. In the below image, we can view this flow accumulation raster to see where we begin to have concentrated flow paths. For example, as more upstream cells begin to converge, we can see those concentrated flow paths in green. And then the more that the flow is converging, the darker the color eventually turning blue. This allows us to view flow paths throughout the watershed and begin to estimate where a channel may begin. Behind this flow accumulation raster in yellow, we can also see our 4th output, which is the hillshade. The hillshade will mostly be used for visualization purposes and to understand our terrain's characteristics. Once the D8 terrain processing tool is finished running, the outputs are automatically added to our map. First, we can see our hillshade, but we'll turn that off for now by unchecking the box next to the layer in our table of contents titled HSHD. Next, we have our flow accumulation titled D8 Flow ACC. Currently, it does not look like much is going on, but we will take a look at that in detail in a bit. And third, we see the flow direction raster titled D8 Flow DIR, which has had the symbology changed and looks absolutely crazy. And then we have the filled DEM titled DEM Fill, which at the moment looks just like our original DEM, though the sinks have been filled. As you can see, we are unchecking all, and we will turn the D8 Flow ACC back on with all within our table of contents. Right now, we're not seeing much with the flow accumulation, but with some visualization, we'll be able to see a whole lot more. We can do this by changing the symbology of the flow accumulation layer. We can get there by right-clicking on the flow accumulation layer in our table of contents on the left of our screen and choosing symbology from the menu list. A symbology window will open in the same panel that contains our catalog and geoprocessing windows. Currently, we can see that our layer is symbolized with the stretch method. For these visualization purposes, we will change the color to the purple-green continuous scheme. We can access this color scheme by clicking the drop-down for the color scheme, checking the boxes next to Show Names and Show All, and then dragging our scroll bar down towards the bottom until we get to purple-green continuous. Click on it to set it, and now we will change the statistics setting. Click on the drop-down next to statistics, and we will be choosing DRA, which we can see stands for Dynamic Range Adjustment and uses statistics from the current display extent for visualization. We will click on it to choose it. If we zoom in on our flow accumulation raster, the display will change due to the DRA. We can zoom in by either scrolling with your scroll on your mouse, or if Explore is selected, holding Shift and dragging a box. You will see the magnifying glass with the plus sign to zoom in. The further we zoom in, the more the flow paths will start to appear. The background is still purple because that is indicating our lowest value. To recap, the D8 terrain processing tool uses a DEM and Z factor to produce a filled DEM, flow direction, flow accumulation, and hill shade. You can edit the flow accumulation symbology to better visualize flow paths. In our next video, we'll be able to start using these layers to start an iterative editing process for hydro conditioning.